All right, so the number of people living in an apartment building was 2,000 in 2015. So in the year 2000, there was, or I said that backwards. In the year 2015, there was 2,000 people. And they are telling us here, that's population, that's a year. And they're telling us that the population was projected to decrease by 20% each year. By 20 people. I said percent, but I says 20 people each year. Based on this projection, which of the following expressions models the population of the community T years after 2015? Well, because it's decreasing by 20 people each year, that is a linear model, because it's just decreasing by a constant amount of people each year. So what that allows us to do is that allows us to get rid of C and D right off the bat, because C and D are exponential functions. We can get rid of those. This is a linear function. Now, if we think about it, I mean, we should be able to write this out. We should just be able to write this out because it's 2,000 people in 2015, and then it decreases by 20 people each year. So it should just be 2,000 minus 20 people per year, and t is the number of years. So it should be 2,000 minus 20t. Yep, okay. Well, let's just take a look here. Let's move this down so we have some room. Yeah, if we look at A, we just have to kind of simplify these things. Like, we know what we're looking for, and they're just in a different form. It's factored out. So if we factor the 2,000 out, but if we just work backwards and distribute, let's look at that. A, if you distributed that thing, that would be 2,000 times 1, which is 2,000, minus 0.01t. So that's moving the decimal place over, 2 units. That's just division by 100, right? So that would be minus 20t. That looks good to me. Pre-circle, but let's just go ahead and double check. Same thing, 2,000 minus, and now when we divide by 0.1, that's division by 10. And that's going to be 200t. So, yeah, confirmed A is the right answer.